Baruch is a principal developer and productivity engineering advocate at Gradle. Together with him, we are going to embark on an exciting journey into the intersection of psychology, software development, and developer productivity engineering.
Thank you. And all of that, let me add, while being a time traveler, I can see that from his hat.
Yeah.
And also a Nobel laureate. No, this is another one. Sorry about that. Only time traveling for this guy.
Yeah, no, the Nobel laureate is not me. It's Daniel Kahneman.
Yes, sorry about that. Sorry, guys. It's been a long day. But
Oh, yeah.
The stage is yours.
Thank you.
Sorry about
Yes.
Yeah, so Daniel Kahneman, almost my co-speaker, almost. We're going to talk a lot about him. He's not here. But yeah, we're going to talk about the cognitive aspects of developer productivity. And we will see how Kahneman's insights that actually brought him the Nobel Prize can be applied to improving developer practices and efficiency. So yeah, my name is Baruch Sadogursky. I'm at jbaruch at whatever social media is trending this week. Developer productivity advocate with Gradle. Who heard about Gradle? Yeah, here we go. We're not going to talk about Gradle, almost. Been a developer for more than 20 years by now, and then spent the last decade in the DevOps space with a company called JFrog. And now I'm talking about developer productivity in general and developer productivity engineering, DP in particular. Co-author a couple of books, DevOps tools for Java developers, kind of bringing together my DevOps and Java expertise, and Liquid Software, about releasing software in proper way in this day and age. The most important slide of this talk is this. I prepared a special page for you at speaking.jbaruch. You go there and you find the slides already there. The video that I'm recording, the organizer is recording, one of them will happen, and I'll put it there. And all the links for everything I'm going to talk about. There will be a lot of book recommendations, like a lot. All the books are in speaking.jbaruch. You don't need to remember it right now. It's in the bottom of every page, together with my Twitter handle and a couple of hashtags, OpenConf, obviously, and also DPE for developer productivity engineering, as I mentioned. So, yeah. Let's get into it. Daniel Kahneman and Thinking Fast and Slow. That's a very, very interesting book, very insightful. It kind of goes about how we have two systems in our head. Daniel calls it System 1 and System 2, and we're going to do an experiment with all of you that will prove you that System 1 and System 2 actually exist. So what I want to do now is I'm going to ask you a simple mathematical question, and I need you to answer immediately. It's very simple, so I don't expect you to take any time thinking it. Just shout the answer, okay? Almost. So here we go. A bat and the ball cost $1.10 in total. The bat costs $1 more than the ball. How much does the ball cost? 10 cents. Most of you said 10 cents. And this is fine, but if you think about it for a second, if the ball costs 10 cents, the total cost will be $1.20. Now, whoever said 5 was correct, and they probably knew this riddle beforehand because, yeah, I know you're cheating, it's fine. Because the first thing we want to say is, it's obviously 10 cents. But when you think about it for a minute, you get this. It obviously cannot be 10 cents. It doesn't make sense. Obviously, all of you know that. That's like a basic math. So why didn't you answer correctly immediately? You didn't answer correctly immediately because there are two systems in our head, right? We have the system 1, which was the system that answered 10 cents immediately. It's very fast, as you noticed. You answered immediately. It's intuitive. It jumped to this conclusion because it feels right. There is $1.10, the difference is 10 cents, boom, 10 cents. This is your intuition working. It's automatic. You couldn't switch it off. You had this answer before I even finished to ask the question. It's automatic. It's emotional. You're like, you're happy. Yeah, of course I know the answer, right? And it's very eager to answer, right? You wanted to answer 10 cents. You didn't want to spend any more time thinking. You didn't say, well, wait a second, there is something wrong here. I need to think about it. No, you just went ahead and answered. And this, it's not a bad thing. System one, so I obviously tricked you with a trick question. And it was fun, but most of the cases in our world, 99% of the time, system one is spot on. If this question wasn't engineered to trick you, it would probably be some simple question, and the answer would be correct. So there is nothing wrong with system one. It's great, and it's cheap. You engage system one most of the time, and you don't get tired of answering those simple questions. We can go all day. Most of them will be correct answers, and you didn't break a sweat. You can do it all day. Now, there is system two, and system two engaged when you realized it's a trick question. When you realize it's a trick question, you're like, okay, I need to think about it for a second. I need to apply analytical thinking. I need to do some math. I need to do like, okay, $1.10 plus 10 cents, 120. Well, that's not right. It is controlled. You don't rush to give an answer. You take time to think about it. It's logical, obviously, because that's what you do. But it's also expensive and lazy. Lazy means it's not the third thing that you do. When you need to answer a very simple question, you are not going to engage your system two. And it's lazy because it is expensive. Now, what do I mean expensive? Obviously not money. And for prove you that it is expensive, we're going to do another experiment. Now, this one is going to be fun as well. Now, what I need you to do is to remember the following numbers. It's important that you remember them because we'll get back to that. 3, 4, 6, 8, 7. 5, 6, 8, 2, 0. 7, 6, 3, 7, 8. 9, 0, 8, 2, 4. One more. 1, 1, 2, 4, 7. Now, try to remember them, well, as much as possible. Obviously, I know it's hard. But try to remember that. Okay? Now, what we're going to do is, I'm going to show you a slide with a color written, like a word of a color. What I need you to do is to shout the color of the letters and not the word. Ready? Okay, shout. Yeah, okay, yeah. That's, it's something with the colors here of the screen. This is actually blue, but it's okay. So most of you managed well because you knew that the trick is coming. But I also heard some incorrect answers, and that was, again, that's fine. The experiment was, I tried to load your system too. Remembering random numbers, it's hard on your system two. Your system two is engaging. You have to think about it. You have to repeat those numbers in order to remember them. It's really, really hard. And then when you work on it, you spend mental fuel. And when you spend mental fuel, distinguishing between the word and the color is hard because you don't have unlimited capacity for system two. System two is expensive because it spends your mental fuel. You have it, and it is something that runs out. Now, Daniel Kahneman spoke about System 1 and System 2 from the perspective of behavioral psychology. He studied people, he did experiments, like those experiments that we just did together, and he came to the conclusion that there is the System 2, and the System 2 is expensive to engage, and you run out of your mental fuel. In Daniel's terms, it's called the ego depletion. Now, since he came up with this idea, neuroscience proved that he was correct. And here is one of the papers that actually proves it. It calls Attention and Capacity Limits in Perception, a Cellular Metabolism Account. Now, if you're wondering if you want to read the entire paper, I remind you, if you go, here you go. If you go to speaking.jbaruch, you can find all the links there, including the link to this paper. But I will summarize it for you. It's full of very interesting diagrams that I have no idea what they mean. And it's basically like terms like OXCCO and what's not. I have no idea. So when I don't know, just go to ChatGPT and say, hey, explain the paper Attention, Capacity Limits, and Perception, Barney style. Barney style, you know what? This is a very useful presentation. Who knows what Barney style means? Yeah, one hand. Okay, I'll tell you. It's actually a term from American military. Barney is a dinosaur in the very funny one in child TV show. And Barney explains stuff for children very, very simple level. So when in American military someone explains Barney style, it means break it down like it was for 5 years old. So yeah, Barney style. All right, imagine your brain is like a smartphone battery that drains as you use apps. The paper says our brain has fixed amount of the energy for tasks, like the phone battery has limited use. When you do something that needs a lot of focus, it's like running a power-hungry app. It uses more of your brain's energy. And just like closing apps to save battery, your brain tries to save energy by paying less attention to less important stuff. This is exactly what Daniel Kahneman spoke about with System 2, right? And basically what it says is, okay, I have to read it because I have no idea what it means. Broader near-infrastructure spectrology, BRINS, was used to measure oxidation states of cytochrome C oxidase. Obviously, duh. Okay, whatever. Cellular metabolism is the right technical term for mental fuel that we spoke about. And it has a finite energy supply. It runs out like the battery. And you can run it in two modes, in high load mode and in low load mode. And this is your System 1 and System 2, striving to save energy and all this stuff, right? So this is brilliant. Now, getting back to our comparison with System 1 and System 2. What skills do we need for software engineering? From here, tell me. Analytical, logical, controlled, right? Those three are software engineering. So basically, it's very clear that software engineering is System 2. And as we spoke, System 2 is expensive. Now, there is a workaround of spending a lot of System 2 energy for software engineering, and it's called the flow. Okay, now the name of this guy I need to read out. Mihai Csikszentmihalyi came up with the term flow. And everybody knows what the flow is, right? It's when you code and you're like in the zone and there are no distractions and you just like, you're in the flow. So the way he explains it is state of effortless concentration so deep that people lose their sense of time, themselves, and their problems. Now, it gives me goosebumps when I read it because this is one of the most amazing things that humans can do. It's true for artists, it's true for musicians, and it's true for software engineers. We go into the flow and we deepen it, and it's really amazing. Now, I want you to pay attention to one word in this definition, and this is effortless. Now, this sounds counterintuitive to the whole concept of we use System 2 for software development. How it can be effortless? The answer is one of the most important, of the most wasteful activities during software development that uses a lot of System 2 is attention control. Attention control is extremely expensive, being especially for software developers. A lot of us suffer from or benefit from attention deficit disorder. I think it's a benefit, not suffering, but it really means attention control is very expensive. Trying to focus, trying to concentrate is very hard. Now, when we are in the flow, we concentrate naturally. And this expense does not exist for us anymore. And this is why the flow is effortless, regardless the fact that it's most obviously System 2. Now, what ruins the flow? And generally, what makes attention control so expensive are interruptions. Interruptions. We all know that, we all live through that. Another very, very important scientist is Gloria Mark. Gloria Mark studies focus, distraction, and attention for years. She wrote a number of very important scientific papers, and just recently, just this year, she summarized all her findings in an amazing book called Attention Span. And you know where to find it, right? You go right there, and there is a link to the book. Now, couple of conclusions from attention span. We check, average person, we check their email 77 times a day. Our attention span is usually no longer than 47 seconds. Try to write code while checking emails 77 times and concentrating on something for 47 seconds. The most painful finding, for me at least, was it takes at least 25 minutes to return focus to a task after disruption. You got distracted from writing code. It will take you 25 minutes to get back to concentrating on writing code. This is horrific statistic, really terrible. Okay, another experiment. I know you like those. This is a Python code, and being Python means everybody can read it regardless of what programming language you write. There is a mistake here on the page, pretty obvious. It's not syntax. You don't need to know Python to recognize it. It's not even a mistake. It's more like of a bad practice. Who can tell me what the problem is? Oh, yeah.
The price times discount divided by 100?
Yeah, what about it?
Shouldn't it be discount divided by 100 and then multiplied by 100?
Oh.
That works either way. Clearly, I don't know. I need a pen.
Oh, no, it's fine. You don't need a pen. It's like, you're fine. How do I say it? It's more of a usability issue than actually a bug. Print statement, what about it? Huh? It's in a function? Yeah, no, it is. Yeah, no, the quotes are fine. Huh? VF? Oh, no. That's fine. Yeah. Huh? I'm not using the return value. It's fine. I don't need to use the return value. Yeah, okay, the function name is wrong. Right. There are actually two options. I wanted to see what will be first, but first, yes, I don't calculate the discount, I calculate the final price. And it also will print something really ugly if, for example, the discount is 30, like 1/3, right? It doesn't do any routing or formatting. Good. It took you, what, less than a minute to actually find the problem. Very cool. Now, I'm going to overload your system 1, not even system 2, with something completely unrelated to code. Count the triangles. System 1, like, there is nothing nothing comprehended here. It's system 1 counting. 9, 10, 15, 16, 17, 18, maybe not. I don't know, 19. Seven, 12. Okay. All right. Okay. The correct answer doesn't matter. It's actually 18, but it really doesn't matter. I took you off the context of code. Let's get back to code. What's wrong here? Same thing as before. Yeah, okay. One more. It doesn't calculate tax, it calculates the total amount. Yes, that was exactly why it's here, so you'll recognize it as almost the same code. But there is something more. Huh? I add the tax. Yeah, here you go. All right. It's not divided by 100, right? The tax rate should be divided by 100. Now, this is much more obvious. Much more obvious. There is nothing here that hides the error. The error is right here. And still, it took you some time to actually find the problem. And, you know, only a couple of you did. And the rest of you are still searching. Because I broke your focus with the context switch. The problem is context switching is very expensive, and we deplete our fuel just by doing so. By coming back to the problem later, very expensive. And context switching prevents you to getting into this fuel-efficient, fuel-saving mode of flow. So it's actually a lose-lose. You need more fuel, and you actually don't save fuel because you're not in the flow. Context switching is killing your productivity. One more scientific paper. Speaking.jbaruch is where you go to get the original. Characterizing and predicting mental fatigue during programming tasks. University of North Carolina together with Microsoft. They have extraordinary findings. For example, developers are cutting corners on quality when they're tired. And you're like, okay. But you know what? Scientifically proved. You cannot argue with that. So, when you're tired, what would be the expected, and I would say the optimal outcome? You'll just quit. You're like, okay, I'm too tired for today. I cannot think straight. I quit. The problem is, this is not what's happening, because we don't know where to quit. Back to Kahneman. One of the most amazing findings is that we don't know how to quit. There was a study performed by Kahneman and his colleagues among parole judges. They observed how they work throughout the day. And they found an amazing thing. They issued fewer paroles when they are tired and or hungry. Now, those are professional judges. They obviously didn't do it on purpose. If they knew that their ability to judge the cases degrade, they would obviously stop. But they didn't do it. Granting parole requires system 2. Denying parole requires system 1. The default is to deny. To grant requires mental fuel. They are tired or hungry, they don't have the mental fuel, but they are keep going. They didn't realize they switched to system 1 and started to deny on autopilot because they are tired. Obviously not on purpose. They are professionals. They would stop if they knew that they are tired, but they didn't know it. So the real life outcome is that we don't stop when we are tired. Instead, we default to system 1 because system 1 is cheap, system 1 is eager, system 1 is ready to step in every time. The problem is when you code with system 1, you code on automatic and on emotional. What does it mean, coding on emotional? It is about pattern recognition. It's keep doing the things that you know that will work, and you kind of generate code that works, but it is what I call an okay code. It's fine, it works, but it's definitely not your best code. Not great, not terrible. Now, I will ask you a question. Who thinks that straight out bad code is better than okay code? Well, a couple of hands. I appreciate this opinion. I would argue, and I guess the rest of you will agree, that okay code is worse. Because bad code is out there for everybody to see. You're not the only one who looks at your code. There is your pull request review. There are your quality gates on CI/CD. You can see bad code. Okay code flies under the radar. It looks okay to us because we are tired and we run on system 1 without even recognizing it. It looks okay to people who review our pull request. Why it looks okay to them? Because they run on system 1. Not because they are tired, but because they review our code with the lazy and the cheap system. They have more important things to do. They have their own code to concentrate. They will spend their mental fuel on their code. For the code review, cheap and fast, system 1. It also looks okay to our pipelines. Why is that? Pipelines, as any other algorithm, which system it uses? System 1. All the algorithms are always system 1 because this is how algorithms behave. You cannot write an algorithm that will be system 2. So any algorithm in system 1. And this is how your okay code flies under the radar all the way to production. And next thing you know, you have an okay product. And this is not something you want. So how can we solve this problem? The solution is we need to invest in fuel-saving techniques. I will give you a bunch that you already know. I will just ask you to pay attention. Stuff like, and obviously our goal is running on system 2 all day long. Management strategies like time blocking, Pomodoro technique, task batching, doing similar tasks together to avoid context switch. Mindfulness and cognitive practices like meditation, like reflective practices, Single tasking, multitasking is a lie, even for women. Workspace and interruption management. Workspace organization. This is where your noise cancellation headphones that you might have won on this conference or another are very, very handy. Notification management, turning off your notifications. You all know this stuff. Prioritization techniques, doing what requires more system fuel in the morning and something that you can do on automatic without harming the quality in the afternoon. Physical and mental well-being, physical exercising, and scheduling breaks and downtime on your terms and not because you depleted your system too on stupid shit like Facebook. This is where it's important. The last but not least, and I have 8 seconds to talk about it. I'll run a little bit over, is developer productivity engineering. Developer productivity engineering is the engineering aspect of saving fuel and running on System 2. Foster faster feedback. That's the most important one, and this is the most obtainable one. Faster feedback allows you to avoid context switches. We're going to talk about it in a second. Eliminate toil for developers. Toil generates context switches. If you go and eliminate stuff that requires your babysitting and you can automate it, do that. Collaborative through effective tooling. If you can send a link to a problem to your colleague instead of trying to explain it to your colleague, it will save you a lot of fuel. Prioritize automation and eliminate bottlenecks. Stuff that has been done automatically doesn't require your attention. You save context switches. Embrace rigorous observability and proactive improvement. Make sure that whatever you did in eliminating toil, automating, and fostering faster feedback doesn't disappear. Outcomes over output. Output is overwhelming. Everything generates tons of output. This output is very distracting. Try to squeeze outcomes out of all this output. And organizational mindset. Your organization have to pay attention to this stuff. Foster faster feedback. A couple of more points about that. What is feedback and how important it is for us? We write code in our IDE. Our feedback is immediate, right? Especially after you got those, you won those IntelliJ and JetBrains certificates. Now your feedback even better from IDE. Build. You expect your build to be very fast. CI, well, suddenly you care less how long CI is. And feedback for production, it's important, but you definitely do not wait for it. So it's a reverse dependency on distance from developers. The closer it is for developers, the more interested we are in faster feedback. Now, the reality is not so much, especially the build hurts us. Who has built under a minute? With tests, with everything. Couple of hands. How about under 10 minutes? This is the majority, I expect. Well, a little bit less. Under 20 minutes. And then, yeah, okay, I feel you. And the rest is I feel you dearly. Okay. Now, there are two types of feedback, asynchronous and synchronous. Asynchronous is your CI/CD. You never wait for it. It takes whatever it takes. It takes half an hour. Fine. The problem is, if your CI/CD breaks, it's very distracting. It brings you out of your flow. This is the context switch. But it happens rarely. Why? Because you do local build. Local build is synchronous. You expect it to be fast because you wait for it while you're in the flow. You wrote something, you run it, 5 seconds, fine. You have your answer if it's good or not. And if it's slow, it pisses us off because it's lose-lose when it's slow. You either wait for it for a very long time or you context switch, and we just spoke about how terrible it is, right? So making your build fast is very important, right? This is what we want to do. Synchronous should be very fast. Asynchronous, we don't care. Foster faster feedback saves mental fuel. It's exactly about that. Speeding up local build minimizes context switch. Less context switch saves mental fuel. And then you run on System 2 all day long. This is where we want to be. How can we engineer less context switches? Measure local build times. Maybe you don't even know that you have this problem, and you're just so used to do the context switch you don't even realize it. Measure it and check. Avoid building and testing what didn't change. Use the build tool that allows you to do that. Speed up what cannot be avoided. And that means your local machines should be very powerful. So your builds and your tests will be very, very fast. Flaky tests, they are very disruptive. Pay attention, nudge whoever is in charge of fixing them and fix them. And watch your build for degradations, because when it slips back, you will start multitasking, context switching, and depleting your system, your system to fuel. Don't do that. Right? Stuff you can do today, a lot of them. Parallel local builds, running your builds on all the cores that you have on your machine. Local caching, remote caching, you can do it almost for free. Build scans to analyze your builds. And win prizes. If you go here, there are fun challenges with builds that you can win prizes. What your company should pay for, all the books that I mentioned, they really should buy it, pay for it, see the show notes. Top development hardware, as I mentioned, you want faster local builds. And stuff like tools like Gradle Velocity, that's how they pay me for being here, for you to hear this name from stage. That's the end of my product pitch. And learn more and try today by going to speaking.jbaruch. There is a Gradle and Maven speed challenge that will help you get your build faster. Developer productivity engineering, agent of change. All of you, if I convince you that it's important, go ahead and do that. Read the DPE handbook and watch the DPE summit videos. They are going to be published, I hope, this week. With that, no time for Q&A. A little bit time for Q&A, yay! And I'm at JBaruch, this is OpenConf, and speaking.jbaruch is where you go. Yes?
Yes.
We can have. I think that we can have one or two. Why not?
I always love a good example. I loved your example about the judges and the paroles. It makes me thinking, if I ask for a promotion from my manager, should I give him a sandwich first?
Okay, yes. After lunch, not straightly, not where they are food coma,
right,
but before the end of the day. So if they have their lunch about 1, like until 2, I would say 2:30.
Perfect.
What if he doesn't like turkey?
What can you do? You're doomed.
So let's move with the questions. Do you think we can use simple but effective thinking shortcuts to make our development process more efficient without sacrificing quality?
Yes. So I would say the most important thing that we can do today is be aware of the interruptions, right? Spend a day really trying to pay attention, maybe writing down stuff that interrupts you. And you will discover that it will be in this order: meetings, build, right? Meetings, I don't know what you can do about it. Maybe you can, maybe you can't. Try batching. You remember the batching, task batching? This is important. Try to get all your meetings together so you can concentrate before and after. And build, speed up the build.
So we have another one. The concept of going into the flow is contradicting the pair programming concepts from the first speech from Michael and Selena. Both sound quite beneficial for day-to-day work. Could we combine both concepts?
Mike and Selena, that's a question for you.
You can come running here if you want to.
Come on.
Just don't drip any sweat on me.
They've been running too much today. Let them rest. Yeah, no. So, I think it's a fascinating question, and I really think that Mike and Selena might have some insights into that. I don't have an answer. Maybe kind of doing a little bit of that, a little bit of this, maybe. But it's a good question. I don't know. Yeah. Yeah, you have the mic, but it doesn't matter. It's not on, so I will repeat. Yeah, Pomodoro technique is very good. And Pomodoro, it's batching your tasks in batches of 25 minutes. you work for 25 minutes, and then you have some time for interruptions, and then you work for 25 minutes again, and those 25 minutes really should be either in the flow or in pair programming.
That's right. And even
There you
if
go.
you're pair programming and you do these Pomodoro techniques, maybe one Pomodoro you're actually soloing because somebody's off doing something else. 25 minutes, you won't be so far off that the other person can't catch up the context as well.
Okay, so you work in pair programming for 25 days, and then you go into the flow. Both of you go into the flow for the next 25, trying to kind of implement maybe what you discussed or this kind of stuff, right? There we go. We have an answer.
Awesome. So Baruch is the embodiment of his speech, having all the gears on his hat.
Yes.
This is system 1 and system 2, guys,
Exactly.
as you can see.
Yes, and all the gears that spend all this fuel. Yep, exactly.
Yes, this is the mental fuel.
So this is for you.
Thank you very much.
Thank you so much for
Thank you.
coming.
Thank you.